All right, so I'm going to cover two more methods on how to take derivatives of functions. So one of them is the product rule, and we use the product rule when we're taking the derivative of a function that is two separate functions multiplied together. So let's define what the product rule is. So let f and g be continuous functions for all values of x. So here I'm going to write this. This just means for every value of x in the real numbers. So a function f multiplied by g prime is equal to the derivative of the first function times the second function plus the first function times the derivative of the second. So let's look at some function. I'm going to call it h of x. And let's say our h of x is equal to 3x squared plus 4x, and it's being multiplied by, let's do sine of x. Well, here we can separate these two functions, right? Let's let f equal our 3x squared plus 4, and let's let g equal our sine x. Well, here f prime is equal to 6x, this should be a 4x, plus 4, and our g prime is going to equal cosine of x. Well, now we have all four pieces of information to plug into our product rule formula. So h prime of x is going to equal f prime, so that's 6x plus 4 times g, which is sine of x, plus 3x squared plus 4x times g prime, which is cosine of x. All right, let's do another. So let's call this function j of x, and we will have j of x be equal to x squared times tangent of x. Well, same thing applies. So we'll let f be x squared, and we'll let g be tangent of x. F prime is equal to 2x, and g prime is equal to secant squared x. So now we can find the derivative of j of x by just plugging in our values into our product rule formula. So j prime of x is equal to f prime. So that's 2x times g, which is tangent x, plus the derivative, or plus the first, so that's x squared times the derivative of the second, so that's secant squared x. Little parentheses around here. All right, so next we have what's called the quotient rule. So the quotient rule is kind of like the product rule. So let's let f and g be continuous functions for every x as an element of the real numbers, then f divided by g prime is equal to, there's a little saying for this, it's low d high, so the function on the denominator times the derivative of the function in the numerator, low d high minus high d low over low or low squared. So let's take a look at a function that requires us to use the quotient rule. So let's say we have a function a of x, and a of x is equal to x plus 1 divided by x squared. Let's test it out. So a prime, or let's define what our f and g are going to be. F will be equal to x plus 1, and g will be equal to x squared. So f prime is equal to 1, and g prime is equal to 2x. Now we have everything we need to plug in to our quotient rule formula. So a prime of x is equal to low d high, so that's 1 times x squared, minus high d low, so that's x plus 1 times the derivative of g, which is 2x, all over low, or g squared, so that's x squared squared. All right, well now we can simplify this. So a prime of x is equal to, let me move down. So a prime of x will be equal to x squared minus, let's distribute this 2x here. So it'll be minus 2x squared plus 2x, all divided by x squared. Quantity squared is x to the 4th power. All right, let's continue to simplify. So when we distribute this negative through, we will get x squared minus 2x squared minus 2x over x to the 4th power. X to the 4th power. My bad. I don't know why I just wrote 4 there, but it's x to the 4th power. And a prime of x is equal to, so x minus 2x squared, that's negative x squared minus 2x all over x to the 4th power. And we can continue to simplify this. What I'm going to do, we could just do it this way. All right, so negative x squared over x to the 4th power minus 2x over x to the 4th power. So this will be equal to negative 1 over x squared minus 2 over x cubed. And that's our derivative, a prime. All right, let's do another example. Let's do f of x equals tangent x. Well, finding the derivative of tangent x actually requires us to use the quotient rule, because another way that we can write tangent of x is sine x over cosine of x. So let's apply our quotient rule. So f prime of x equals low d high, so the derivative of sine is cosine, so cosine x times cosine x minus high, so sine x, d low, which is cosine x. Derivative of cosine x is negative sine x, all over low, which is going to be cosine squared of x. All right, let's simplify. So f prime of x equals cosine times cosine is cosine squared x. Sine times negative sine is negative sine squared. So minus negative sine squared x divided by cosine squared x. Sorry, my lights just turned off. We can still see though. All right. So f prime of x is equal to, so cosine squared minus a negative sign, we can just say cosine squared x plus sine squared x all over cosine squared x. So here in the numerator, we can see cosine squared x plus sine squared x. That's the Pythagorean identity. So we know that cosine squared x plus sine squared x is equal to 1. So f prime of x equals 1 over cosine squared x. So f prime of x is equal to 1 over cosine squared x. 1 over cosine x is secant x, so 1 over cosine squared x is going to be secant squared x.